Okay, this is Shane, and it's a video for Lab2. So in Lab2, we're going to introduce still in Sketch geometric constraints, then some other feature commands like Revolve, which is here. Then you have edge blend, then transfer. Then we're going to show you how to make the homework. Just pick some, and then the focus on this video will be on how to create good quality sketch. Because if you're very sloppy on a sketch, you will have a big headache during the modeling process. Alright, so let's start with constraints, and let me build a new file. Again, that's inch model, and someplace you have access, and then Lab2. Okay, then you need to build a new sketch here. So I'm gonna pick XY plane. Alright, now I'm in the sketch. So constraints, which is on the toolbar is here, geometric constraints, right? And that's very useful because we have vertical, horizontal. That's the simplest constraints you have. And why do we need constraints? Well, that's a long story. Then you can look at the reference here, and basically we have three conditions. You have under constraint, fully constrained, and then you have over constraint. Okay, so to demonstrate, I just draw a line here. Now this line is under constraint. Why? You can move it. It's free to move, so it's under constraint. And how do you tell if you active either of the infer dimension or the constraint, geometric constraint tool? You can see something is different. You can see the arrows here, right? That's the degree of freedom arrow. So that means this point can move x direction and the y direction as the same to this one. Okay, so and next I'm gonna show you a fully constraint. Let's say if I gave this a dimension, now the length is constrained. Okay, and before, if you drag this point, the length will change. Now let's put a dimension. Length will not change, but the position also will change. Then once you active the dimension tool, you can see the degree of freedom is still there. Now if I add another dimension from sketch origin to the end point, like so, and you can notice this line, the color changed to green, so that means it's constrained. And if you turn off this, if you drag it, see, it cannot move on the y direction because we have this dimension here. Then if I add furthermore add another dimension from the same spot to y-axis, okay, and you see there are no arrows now. So this time it's fully constrained because you don't have any degree of freedom. Okay, and also look at here, sketch is fully constrained. So now no matter how I move it, it will not move. So as to the benefit of fully constrained, really it's for serious work. If you're in the industry, you probably want fully constrained. Otherwise, anything happens to your sketch, but you just accidentally drag it you change one dimension, then everything flies everywhere. So you want fully constrained. Okay, and over constraint, let's see, how can we do that? So I have defined a dimension, a distance for this point to y-axis. Let's say if I also define this point to be on y-axis, which is conflict, right, to each other. So I can use this point on curve constraint and constrain this point to y-axis. As you can see, it's telling me you're over constrained. Okay. And unfortunately, it's not what I want. Okay. Let's see if I can get something else. Okay. If I have something like this, okay, this line is equals to the length of this line plus this line, right? So I'm giving this line a length. Then do I need to put dimension on this or not? Let's try it. Over constraint, and everything's red now. So that means there are conflicts to each other. Let's change this to a nicer number. 5 inch, 2 inch, 3 inch. You might say that's pretty good, right? 5 plus 5 minus 2 equals to 3. What if I put this to 4? Then there's conflict. So basically you don't need this one because you already have this 5, this 2, and those vertical lines, they have vertical constraints. That means this line is definitely the top line minus this 2 inch. Okay, so that's some concept in the mechanical drawing class or in the drafting class. It's too much to talk about. But only thing you need to know is once you get some red dimensions, how to fix it. Just delete one of the red things. Okay, let's say this is 4 inch, right? And you know it's conflict with 5 inch. If I delete 5 inch, then the top line will grow 1 more inch to 6 inch, and it's fixed. Or you can delete the vertical constraint here. So now it's also fixed. Alright, so that's the way that's a demonstration of fully constrained, under constraint, over constraint. And now we can officially look at this command, geometric constraint. You have those very frequently used constraints. You also have less frequently used. Okay, and you really need to remember those because it will be in the exam, and it's not hard to remember really. I believe most of you already know. Okay, so in case you need other stuff, you can just check them. Then it will be on this selection place. Alright, so let's see. Also, I'm gonna introduce display sketch constraints. It's rarely used because you always want to see constraints, so you know why what constraint you have. Like if you uncheck this, you don't see any constraints. So you would probably think, okay, I can put a 4 inch here, then this line will go tilted. However, if you display your constraint, you know where they are. So you always want to keep this on. Also, you always keep this create inferred constraints on. By default, it's on. So just in case, like if you have a rectangle here, it will automatically add constraints. Just in case you accidentally disable this, then for the rectangle below, it doesn't have any constraints. Okay, if you move, it just explodes. If you move the top one, there's constraints, so they will move together. So once you have this kind of situation, you want to enable this inferred constraint. Alright, now show constraints, you can try it yourself. And move objects, we introduced that in Lab 1. Basically, you just drag whatever you want to move. If it's not constrained well, you can pick everything, then move. So it will keep the shape. Then, if you want to rotate, which is also one of the moving, you cannot drag. So now you can right click, right click on line, then that's move object. Also it's here. You can even move object in 3D space, like move object. You can move a sketch and in a 3D space. Okay, so in this move object command, you have a lot more options. Okay, then let's go down to hide and show. In the sketch, it's not very critical. It's not very that useful. Like you won't want to hide this line because you want to see whatever all the stuff on your in the sketch. Okay, but let's say I finished this sketch, then I extruded this sketch, right? And you see this blue line down there? It's kind of annoying, right? And let's say if I have another sketch on this top surface, like just a quick reminder, sketch can build on datum or surface face, right? So I'm gonna build another sketch here, and you see that the solid, you can see the solid, and you can see the first sketch in your second sketch, and if you draw anything, it will snap to that. Sometimes you don't want the interference from the background, so what we do, we right click anything you want to hide, and that's the icon for hide. Also you can see from here, so hide the extrude, also hide the first sketch. Now you have a very clear working space. Okay, now whatever you draw will not snap to the corner here. Okay, so that's the option you have. And let's finish a sketch, and you can show it. Right click, then let's show, pick show up, then they will show up. So sometimes people will just, they clear this box. That's not hide, that's suppress. You don't want to do that. So this is basically, it's like deleting the extrude. And as you know, we build sketch 3 on a face of extrude 2. Now you deleted extrude 2. Where's your reference, right? So that means the parent or the parent object is gone. It's deleted. The good thing about suppress is you can always call it back. Just check this box. So this is really more advanced. If you don't want to see this, you just right click and hide it, or just pick from this viewport, then Control B. Okay. Alright, so that's for hide and show. And then let's go to revolve. And if you have something like this, or a cylinder head, a wheel, you want to rotate instead of extrude. It's impossible to extrude the sphere on the top, right? So it's basically similar to extrude. First you build a sketch. Let's say we have this sketch here, and then you rotate. Okay, revolve. So revolve is here next to extrude. Then in this command also you want to pick a curve. Okay. In this curve rule, by default is inferred. So if I pick this one, it will also pick whatever curve in the same sketch. If you want to specifically only revolve this part, you can change this to connected curve or single curve based on your geometry. So I'm gonna pick connected curve. Pick this. So that will be the geometry I'm going to revolve. And let's move down to axis. So there's a couple ways we can revolve this. We can revolve this along y-axis. So you can see here we have vector and point. If you pick a line or one of the three axes, you don't need to pick both. You just need to hit the line. Then it will revolve. Right. Let me change that to 270 so you can see clearly. Because this line has a vector, the direction, that's y direction, and also it has a point, which is the position of this line. Okay. So let me deselect this vector, and here if I pick as they ask, so I can pick y-axis, that's the direction, but I can also pick that's not necessarily this line, because y-axis and this line, they're all at points the same direction. So the vector is the same, but the point is different. So for y-axis, the point is on the sketch origin. You will get something like this. If you define the point to be here, you'll get something like this. See, the vector is the direction, the point is the actual position of your axis. So that you can maybe see better what the point does. So most of the time you probably already have a axis. You just pick them. Like now it goes this way. Okay. Alright, I guess that's enough for revolve. You can use the handle. You can type in numbers until selected. Just try them out. It's pretty simple. Then edge blend. Alright, now we're gonna keep this geometry. So edge blend, sometimes like this cylinder you will have a rounded corner. Then you can use this edge blend command right here on the top. So edge blend, just click on the edge. Now that's the edge blend. You have a little bit more options here. So that's more advanced with continuous curvature. Okay, that's the curvature, and that's circular. Circular is not continuous. Let's try this. Right. So you have different radius, but the curvature will be constant. And circular is just the same radius, but obviously you have a curvature jump from flat surface to a corner circular surface. Alright, and sometimes you will need a variable radius point. Okay, so like if I want the radius to be very small here, big there, we can specify a new location for another radius. So you want to move your cursor down here, pick the location you want the radius to be different. So I'm going to pick the end point of this arc, okay, and I'm going to make this really big, maybe all the way to this point. Let's try if I can snap to. Right, if I can't, I just maybe put it like this. So at this corner, the radius is 1.45, and as we did For the middle, that's 0.5. But as you can see, that's the same now. So we need another point to constrain this side. So here, specify new location. You can pick the second point. Now you can change the radius. So let's try 0 actually, and hit enter. Now you have 2 points here. It says the radius and the location of this point is at 1%, 100% of the arc. Anyway, let's finish the command. Then you see the difference. It's a variable edge blend, which is very useful when you have something like has very fancy curve on the top. Okay, and another general technique is you can always go back to one feature like edge blend, extrude. Just double click, then you can edit this, modify this. So let's put this to 0.5, and that will change the geometry. Alright, chamfer is basically the same. Instead of round the corner, it will be straight. You have symmetric and you have asymmetric. Okay, then let's go to homework. So I'm gonna stop the video here. It's easy.